next speaker, Subodh, will tackle some of the process challenges of sustainability, finding ways to harvest and break down recycled materials more efficiently. Dr. Das wears many different hats. He's a scientist, engineer, inventor, and entrepreneur. Dr. Das is recognized as a global thought leader in the area of aluminum, recycling, sustainability, and carbon management. He has founded 6 research companies and consortia, 3 of which are Phoenix, Fluid Management Systems, and Underground Recovery. He has served as director of the Center for Aluminum Technology at the University of Kentucky and has held executive research and manufacturing positions at Arco and Alcoa. Dr. Das?
Good afternoon. A quiz. How many people remember seeing movie Graduate in 1976? Okay, so this is the 43rd most popular dialogue of any Hollywood movies. Benjamin, played by Dustin Hoffman, comes to Mrs. Robinson, and she says, Benjamin, I want to say something to you, one word. Would you listen to me carefully? And Benjamin says, yes, I'm listening, Mrs. Robinson. What is the word? The word is plastic. Now, if the role was played today, Mrs. Robinson will say to Benjamin, the word is scrap. Not crap, scrap. So my talk today will be basically why scrap is important for the global sustainability and how science can get involved in scrap and create jobs for all of us. Okay. Just a brief background of the aluminum industry. Basically, you mine bauxite in Guinea, very far out places, and then you refine to alumina, and then you smelt it mostly in China now, and you process that product mostly in US, lots in Kentucky, and then you recycle. So that's a chain of the process. Now, why is Kentucky, what's the big deal about aluminum in Kentucky? Well, the average job, aluminum jobs in Kentucky is about $52,000, which is good salary, and it employs 15,000 citizens, and it generates about 100 million yearly revenue in state and local, and shipment is $2.5 billion. Primary aluminum is the largest in Kentucky in the US, and total GDP is over $4 billion. So aluminum is important to our economy, but things are changing. And what I want to emphasize is that what are the changes and how can we transform the changes into opportunities in terms of research, and jobs. Okay, the first simple, as we know, there are 11 states in the nation that have deposit laws, meaning that when you buy aluminum can, you have to pay deposit, and when you return it, you get it back. Unfortunately, Kentucky is not one of those 11 states. Based upon some information from Container Research Institute, one of my students did some research, and we found out that based upon the Excel sheet that they have, if the deposit laws are enacted in Kentucky, 5 cents, it would create 847 new jobs. 10 cents, 963 jobs, and 15 cents, it will create over 1,000 jobs. Now, to bring 1,000 manufacturing jobs in Kentucky, we dish out a lot of economic incentives. This is something that can be done rather without much pain and create high manufacturing jobs. So what's happening in the world? Aluminum obviously is important, but the world is changing. Despite all the manufacturing downturns, U.S. is the largest consumer of aluminum products. Actually, U.S. is the largest consumer of everything. The whole world produces copper, aluminum, steel, plastic, clothing, whatever you name it, and we are the biggest importer of everything, which means the scrap stays in U.S. So that's the emphasis of my talk. All the bauxite mining in U.S. is closed. There are only 3 alumina refineries, and they are 1960s vintage. There are only 8 aluminum smelters left. 2 of them are in U.S., and we only have 4% of the world capacity. And electricity cost is pretty high, so aluminum primary industry is basically not sustainable because of the global factors. What remains in U.S. and where the jobs are, where the research opportunity is remelting, casting, extruding, rolling, and scrap, recycling. This curve shows that in 1980, we had 35 smelters in the US. We're down to 8 right now, and my projection is that in next 5 to 10 years, the best case will be 3 smelters, the worst case will be 6 smelters. So smelting industry is basically leaving US because of power costs. So what are the trends in the industry? The first trend goes back to 1950s when safety, and I remember reading, well, accident is part of industry. It was accepted. Well, the DuPont changed their paradigm and say, yeah, zero lost time accident is standard. Now, no manufacturing company right now claim that zero defect is not acceptable. They were out of business. 1970, it was acceptable to saying that smoke and water and landfills, that's part of the manufacturing industry. Now, I do not know of any global companies that will say the zero discharge is not their charter. The quality, Toyota came to US and all the roadside repair shops vanished because Toyota made the product that based on quality, and now zero defect is standard. I'm proposing the carbon neutrality is a new paradigm, and many industries are embarrassing it, but many industries, they are saying it's not possible. But without carbon paradigm, the manufacturing industry will not survive the social changes. So look at the carbon footprint of the industry. Well, aluminum actually is pretty large. I mean, you can see that 1.7% of all carbon dioxide emitted globally, it comes from aluminum industry. Steel is twice as big, but they're making 30 times more material. So you can see the metal industry is very, very carbon intensive. And we need to find a way to minimize that or bring it to zero to be socially acceptable material. Otherwise, society will find alternative materials to use. Now, for aluminum, my guess is that the total carbon footprint for aluminum is 500 million metric tons a year, which is a large amount, and majority of them is coming from smelting. Now, a paper I recently published, and the summary is that how can the global industry reduce the carbon footprint for 500 million metric tons to zero? And to do that, let me first define the carbon neutrality. There's no textbook, there's no definition. So I define saying that the amount of energy required to produce a metal should be less than what is emitted, what is using green energy sources, lower efficiency, and in-use energy-saving products such as trucks and recycling and also urban mining. So my calculations show that if you do these 5 things, it is possible to mitigate the carbon footprint from 500 million metric tons to zero. Now here is the mathematical derivation saying that start with 500, and by different sources, the biggest one is deploying 35% of the product in energy-saving applications such as transportation and other sources. And it is quite possible to bring the carbon footprint to zero. Now, these are not doable today, they're not doable tomorrow, but they are the fertile ground for research and development to make this happen. And the results of the research would be useful not only for Kentucky or for US, will have global impact because industry and economic is very global. So when we talk about life cycle, most people talk about raw materials, production, use, and recycling. I'm saying that unless we do the urban mining, that means what you have discarded in the past for 100 years, we have to find a way to recover it. I always say jokingly that the best bauxite mines in the world don't happen in Guinea, they're actually in New Jersey or Chicago or Las Vegas, because last 30 to 50 years, amount of aluminum products in the landfill exceeds $80 billion. We have been known to go to war for less than that money. So what is one thing we can do? Well, one thing we can do, which is quite a lot of research and development, right now there are 110 alloys that aluminum companies sell to the consumers, automotive, aerospace, building construction. My hypothesis is that we can do the same job with 15 alloys. Now, why companies make more alloys? That is what product differentiation does. That you go to Baskin-Robbins, you get 31 varieties of ice cream. You go to Heinz ketchup, you get 57 varieties of ketchup. Do we need all that? We don't. As the world gets more resource constrained, we have to learn to make fewer materials, fewer choices, because more choices means more waste. The waste in a French restaurant is much higher than a McDonald's, because the amount of menu items in expensive restaurants is 5, 6, 10 pages. And the menu in McDonald's is 1 page. That tells you that more products means more waste. That's one way of doing it. Second, you look at the different products that industry makes, marine to aerospace to packaging, and the alloying element. Most of the alloys are designed by scientists and metallurgists, and I'm one of them. So we love to put elements from periodic table. The periodic table is not for shopping to make alloys. Periodic table is invented to understand what's possible. But by adding zinc in aerospace alloys, we kill it. It's done. You cannot recycle it. By adding lithium, you basically made the whole batch not useful. Aluminum cans. It has 3 alloys: the body, the end, and the tab. And all 3 alloys require 3 separate separation systems, 3 separate recycling streams in terms of collection. And there's no reason why we cannot make all the aluminum cans with 1 uni-alloy, but it's not being done. Same argument can be made for marine alloys, aerospace alloys. So we have a multitude of alloys, and we're adding elements. And remember, every element, by laws of thermodynamics, will increase entropy. That means once you add zinc, the energy required to take zinc out is so much more than energy required to put zinc in. Somehow we forget when we design alloys. So what is the one sustainable message? Most of the primary industry is growing outside U.S., mostly in China, India, Middle East. And recycling is growing mostly in advanced nations like ours. One goal will be for every new incremental production of primary aluminum, we should increase the recycling by 1.05. That means this way we can play in the level playing field, and amount of energy required to make additional term aluminum will be compensated by recycling another extra 1.05 tons. That has to be a global goal, otherwise we can never ever be carbon sustainable. We should be developing internationally accepted carbon credits. We don't have one for recycling, and that needs to be done on industrial level as opposed to individual company levels. Now, this chart is my favorite. I did some calculation, numbers you can debate and we can talk, but basically, if you look at the flow sheet of aluminum in US and Canada in 2009, billions of pounds, you can see that 3.5 billion pounds of scrap is being exported from US. Exporting scrap is exporting jobs. And there's no reason why this scrap should be exported. It's being exported because we do not have good shorting technologies. Because scrap leave San Francisco, Los Angeles, go to Beijing, and it's being hand shorted. And after hand shorting, they come back in Walmart as a product. So now, why cannot we develop technologies that will keep the scrap here and compensate for the high labor costs? That's a research challenge that's not happening. And you can see the trends. We're importing more, we're importing finished product more, and we are exporting product that's declining. What's really going up and up and up is the scrap export is going exponentially. And as a matter of fact, there's the trade deficit that we have in this country. Obviously, this is a big part of that. So here's my last slide, urban mining, and it shows a map of the U.S. and shows all the areas where it has rich bauxite mines like New Jersey and Massachusetts and all the places. And once aluminum can is kicked by this young man to trash, that aluminum can has traveled 7,300 miles from Guinea in Africa to Ireland for alumina, to Iceland, to north of U.S., coming back to Tennessee, and after that, the scrap goes to China, comes back. The total mileage that aluminum can has traveled by the time it is reborn is 7,300 miles. And each can is equivalent to 250 grams of carbon dioxide equivalent. And we can translate all that into jobs. Now, can we do it? Sure. I mean, I went to Copenhagen a couple of years ago, and I saw a taxi. The taxi driver, a Dutch guy, driving a taxi, and there was a motto, and there's a genuine website, I've gone through it, carbon dioxide neutral taxi. So I asked him, how do you do that? Well, we do it by less idling, better fuel mix, less dead weight, and obviously less scenic route, which we like because it will cost us less, driving habits and local offsets. So my point is that if a taxi industry can adopt a motto and live to it, we should be able to do that as an industry. So what's the research opportunity? Well, primary, we cannot, incremental improvements is not going to cut it because the industry already has gone, left the US, they are in Bahrain and Qatar and Saudi Arabia and Abu Dhabi and Oman and China and India, it's gone. So remaining only 8 smelters. So unless we have something totally out of the box, we just cannot compete. Melting, it's hard to believe. Aluminum melting is 25% efficient. That means for theoretical requirement for aluminum melting is 250 BTUs per pound, and average is 1,000 BTUs. There's a lot of research needs to be done. Fabrication, we should be making products that are sustainable and they're recyclable, meaning that recyclability is built in the product design, not after it has been exported to Beijing. We need to develop recycling-friendly alloys, stay away from zinc, stay away from beryllium, stay away from lithium, stay away from silicium. Just don't go shopping a periodic table. That is kiss of death for an alloy. Shorting technology is non-existent because scrap is generated and it's too difficult, so we just pack it up and the truck comes from, I've seen the truck from San Francisco, Los Angeles coming to Lexington, MRF, and you can see Chinese signs. So they're coming all the way, so they can truck it from Lexington to Long Beach in California, take it to Beijing, and bring it back, which is cheaper in Walmart than we can make it ourselves. There's something wrong with the equation. Urban mining, $80 billion, that's a lot of money. And we're adding $2 billion every year because of the 1 million metric tons of aluminum can going down there. And we need to use aluminum where it belongs. It belongs in transportation because every time a car moves, anytime anything moves, because laws of physics, right? Density and specific gravity and melting point, anything that moves, aluminum is a natural. Anything that does not move, aluminum is not a natural product. And will there enough aluminum to do that? I doubt it. Per capita aluminum in China is like 3 kilograms per person. In US, it's 80 kilograms per person. So if all the Chinese using all the aluminum, we want to make sure aluminum is used where it belongs. Windmills, solar energy, and cars and trucks and planes, not to the application where it has no natural advantage. And I guess that's my end of my talk.